Hey everyone, it's Justin again. In the previous video, you learned how to simplify roots, but we all know that sometimes not every value is known to us. So in this video, you're going to learn how to simplify roots with variables in them. This can be a little daunting, but the process for simplification is exactly the same. Let's try it out and see. Like I said before, the process doesn't change, even with variables included. First, you factor inside the radical. If that includes variables, you just expand them. Then, pull out groups. For square roots, the groups will be pairs. For cube roots, you find triplets. Fourth roots will be groups of 4, and so on and so forth. After you've pulled any groups out of the radicals, you multiply the factors on the outside, and then multiply the ones on the inside. I know this example looks a little scary, but watch how easy this is about to be. First, we need to factor everything out. 45 can be factored into 5 times 9, and 9 is 3 times 3. But what about those variables? Well, that's easy. You just expand them. A squared is A times A. B to the 5th power is B times B times B times B times B. And C cubed is C times C times C. Now we just do exactly what we've been doing. Since it's a square root, we pair up the factors. There are 2 3s, 2 A's. Out of the 5 B's, we can make 2 pairs of those, and then a pair of C's. We didn't use every value, so those unpaired ones get grouped together in another radical. Now, for each root pair, we can pull them out of the radical. 3 times A times B times another B times C. And we leave those unpaired values inside their radicals still. Finally, we just need to multiply the factors on the outside and on the inside. So the simplified form here is 3ab squared c times the square root of 5bc. The steps don't change much even with other types of roots. You just have to be careful about how many factors you group together. We could factor 16 into 2 times 2 times 2 times 2. X to the 6th power is 6 x's, and y to the 3rd power is 3 y's. The only factor that appears enough times to pull out 5 copies of, though, is x. Everything else, including the 6th x, goes into a separate radical at the end. So then the 5th root of 5x's is x. There's nothing to be multiplied on the outside. But on the inside, we get 16xy cubed, which is the fully simplified form. If you want an easy shortcut, just look at how the exponents changed. X's power inside the radical went from 6 to 1. It went down by 5 because that's how many we had to group together to remove it from the 5th root. You can use this trick to simplify roots without having to actually expand the powers. Here's one for you to try. Pause the video now and see what you come up with. Let's see how you did. First, we could factor 625 into 5 times 5 times 5 times 5. Instead of expanding the powers, let's use the trick we just learned. Since this is a square root, we need to pull factors out 2 at a time. There are 2 pairs of 5s. Out of 3 t's, we can pull out a single pair with a t left over. There's a pair of r's, and 4 z's means we can pull out 2 pairs. The only factor left underneath the radical is that last t that couldn't be paired. 5 times 5 is 25, times t times r times z squared times the square root of the t that was left over. The simplified form is 25 trz squared times the square root of t. See? Variables don't have to make things harder. We just treat variables like extra factors. In the next video, we'll learn how to simplify roots that are being multiplied by other values. See you then.